Okay, now for problem number 2, we're looking at finding the length of the indicated curve concerning y is equal to 4x plus 3 as x runs from 0 to 3. And now we have a linear function, and so for what we have in the second problem, again we have y is equal to 4x plus 3. X goes from 0 to 3. And to determine the length of the curve, we need the first order derivative of the function. So we have for y is equal to 4x plus 3, we have the first order derivative concerning change in y with respect to change in x will be a constant. And after the attainment of the first order derivative, we now need the square of the derivative. And the square of 4 is going to be at 16. Now, in the case of the length of the curve itself, okay, again, we're going from point A to point B, and we're looking at the square root of 1 plus the square of the derivative. And with integrating with respect to x, okay, now we have with the limits of integration, again, we're going from x equals 0 to x equals 3. So for the length of the curve, now we're going from 0 to 3. We have of the square root of 1 plus 16 dx. And of course, 1 plus 16 is 17. And you're looking at what we have for the antiderivative. Okay, this will end up at x times the square root of 17. And as x goes from 0 to 3, it turns out that for the exact measure of the length of the curve, this will end up at 3 times the square root of 17. And as a decimal approximation, okay, this will be close to 12.37 units.